Hello, hello, hello. 3.2 polynomial functions. So basically what we're talking about, a higher degree is going to be anything with a degree exponential function. Couple of things. This is a polynomial function because it's a continuous graph. If you have something like a piecewise function where you have to pick up your pen, that is not a polynomial function. This is also a polynomial function because it has smooth curves. If you have something like this where it's that is not a polynomial function. This is your absolute value. Now, a couple of things talking about end behavior. When we're talking about end behavior, if we have an even, an even end behavior has my end behavior going either up, up, or down, down. So right now, just looking at this, I can tell that this is going to be odd behavior because it's going down on the left and it's going up on the right. Again, even behavior, if it's going to be a positive leading coefficient, it's going to be up, up. If it's going to be a negative leading coefficient, it's going to be down, a down. And if it's odd, it's going to be down because it's going down on the left-hand side and going up on the right-hand side. Now, if it's negative, that means it's going to be flipped, just like how when this even is negative, it was flipped. So if I'm flipping this, this would be up, down. Another thing when I'm looking at the graph, when you're looking at the turning points can tell you what your degree may be. So in this case, if I have two turning points and it's an odd behavior, that means that this right here could be a degree of 3. So again, when I'm looking at this, I have 1, 2, 3, 4 turning points. It's always one more degree that it could be. So this could be a degree of x to the 5th. This could be a degree to x to the 3rd because of looking at my turning points. So this next question, when I'm asking from the parent function, again, we're going back to this right here. The only difference is this degree right here. So this right here is still going to move it left and right. This right here is going to move it up and down. So I'm asking for this parent function transformation. Because it's inside the parent function, this is going to move it to the left 1. And now I'm looking at my end behavior. So first I have to decide my degree. My degree here is even. My degree here is 4. That means it's either going to be up, up, or down, down. I'm looking at my leading coefficient, so anything in front right there, like my A value. It is positive, so this will be up, up. My end behavior. Right now I want you to pause the video and try to do B, C, D by yourself. So as you can see, whenever we have a reflect over the x or reflect over the y, when we're dealing with polynomials of the higher degree, that's always going to be a flip. That's always going to be a change of my end behavior direction. So again, if you look at how we translated and then our end behavior. So now when I'm looking at these, if I want to state the degree and the end behavior of each question below. Through these problems, I just want you to state what the degree is. Your highest degree is the degree of the polynomial, and then also what is the end behavior. Pause the video and try to do that by yourself right now. Check your work. Always going to back up to this chart if you need to have a reference. Example 3, finding the zeros, the real zeros. Notice how it says real zeros of the function. This is nothing new to you. This is whenever we are solving for an equation. So we have to be able to factor. So I want you to pause the video, set both of these two equations equal to 0, and try to factor both of these two equations and solve for x. So these are what our zeros are. Now getting back into zeros though, I've said this before, your degree will tell you how many zeros you should have. This is including real and imaginary. So I have a degree of 4 here, however I only have 3 zeros. Because this one happened 2 times because of that square, this has a multiplicity of 2. Or you could write multiplicity. Both of these only happened once. So this would have a multiplicity of 1, each one of those. Now your multiplicities, so I have 2 right here. I have 1 for my positive and 1 for my negative. Your multiplicity should always add up to your degree. When I'm looking over here, this 0 has a multiplicity of 1. My 6 value, because it happens 2 times because I factor that, this one has a multiplicity of 2. So again, 2 plus 1 equals 3. That checks out. So even though this is super small space, we're only going to sketch a graph. We're only going to sketch a graph. So a couple things that when I'm going to sketch a graph, I'm not going to actually care about where you're going on the y-axis. I really just care about the x-axis. So I'm going to find my zeros. I have x equals 2. I have x equals -4. This is a multiplicity of 1. This is a multiplicity of 2. So now I know that my degree here is 3. Okay? Again, I'm going to be able to sketch it right in this little spot because I don't need much room to sketch. I also notice that this is my leading coefficient is negative. So this is going to tell me what my end behavior is. My end behavior is going to be up, down because it's odd, and my leading coefficient is negative. When you are graphing and you have a 0 that has an odd degree, it goes through that point. Now, it might go through that point a little bit differently, but I'm going to put a point right there. If you have an even multiplicity at a 0, that means it's going to touch that point and then turn around. I typically, when I'm doing the sketch, I just put a star there. So if I'm starting with my end behavior up, that means I'm going to start above the x-axis. Wherever there's a star, you touch that star and you turn around and then you go to the next 0 and you go through that point. So this right here is a sketch of that. Again, I'm not caring as much about the y. I care more about what the x value looks like. I want you to try to pause the video and try to do B by yourself. So I have an x equals -5, multiplicity of 3. X equals 1 has a multiplicity of 2. That means my degree here is 5, so it's odd. So it's down up because my leading coefficient is positive. Now, I'm starting down. One thing when you have a cube or a 3 or higher degree of 1, you kind of have a little squiggle. If you kind of look at what the cubic looks like, it looks like a little curve like that. So I'm still going through the point. So at -5, I'm still going through the point, and at some point I'm going to be turning around. This happens 2 times, so I'm touching that 0 and I'm turning around. So this is a sketch of that graph. Again, if you were to graph this in a graphing calculator, it might not look like that because I'm not caring about the y's as much. I'm only caring about your end behavior, your zeros, and your turning points. And there you have it. Have a grand, have a wonderful day.